Okay, I'll start. Okay, recording is started. Okay.
Do you want
So
to write?
yeah,
Do you want to control?
no. It will work. I'll tell you like when to scroll and all.
Okay.
Okay. So the first cell that you are seeing now, it is all like importing only. Whatever library that we need for our code running, those are all import. So the NumPy, Seaborn, Matplotlib, those are like data analytics library.
Okay.
Seaborn and Matplot uh, is like for plotting graphs, images, etc. NumPy is purely data analytics library. TensorFlow is a data science library. CV2 is an image processing library. OS is like operating system library. Globe is like also used to handle files, file transmissions, etc. Pandas is also same like NumPy. It is also data analytics library, and
Okay.
all the rest, this TensorFlow, those are like data science and data analytics libraries.
Okay.
Now, if we see the second code here, what we are doing is we are first importing the Google Drive. Okay.
Okay.
So when you run this Google Drive code, it will first ask you like, do you want to connect to your Google Drive or not? It will, and then you will give the permission. Yes, you want to connect.
Okay.
Okay. Well, then what it will do? It will make a full Google Drive copy over to your node, this Google Colab notebook. If you run this one, second code, see, it will ask you to connect to Google Drive. You will give your permission.
Yeah.
Click on allow. Okay. It will takes around 1 or 2 minutes to make a full copy of the Google Drive over to your Google Colab notebook. If click, it is done. Okay, go to your like this before above this search symbol, right? This on the left hand side upper corner, you see the search symbol. Left hand side. Yeah, click on it. Click on it. No. Above the search symbol. Above the search symbol. Huh. Okay, this is not all. Click on this. Okay. See, it is made a folder named Drive in which all the content of your drive is there.
Okay.
Okay, see, it's an like exact copy of your Google Drive. Now move on to the third one, third cell. No, not here. Like third cell in the Google Notebook. Third cell of code.
Okay.
Huh. Now here we are like this. You have to change this drive location as well. Okay, according to where you replace your like where will you will be placing your images and all.
Okay.
Now I am hard coding the images size as can you move the cursor around? Huh. So I am hard coding all the images should be a size of 299 to 299,
Okay.
and I am telling that for each particular run of the code I want 128 images to be pulled at a
Okay.
single time. This is batch size. So for one run, I will pull 128 image. For second run, I will pull 128 image likewise.
Okay. Like that, how,
Now,
like that,
sorry,
like that, so many batches will be there, right?
so many batches will be there. Like according, like if you have 10,000 images, then so many batches of images will be pulled accordingly. Like so, it will be like 10,000 divided by 128. So that many batches.
Okay. Why we are doing batch size as 128? How? Why I can't take for like some other number?
It is an optimal number used in the data science. Like you can change as you wish, but if you change this one, then you have to change other parameters that are depending on the batch size.
Okay. Like, okay. I want to change the batch size number. Do I need to change
You can,
this
yeah, you
here?
can change the batch size as well. See, if you want to iterate over the batch size, you can do it. But the current batch size that I have used now, 128, if you use all the current setting, you will get around 98% accuracy.
Okay.
So like you can check also, you can increase or decrease batch size as well. If the accuracy is increasing, you can use this. If the accuracy is not increasing, you can use the same.
Okay. By using the 128 as the batch size, we are getting the 98% accuracy, right?
Yes.
Okay. Yeah, got you.
Now here in the training data set, I am making my like training data set only. Okay. So
Okay.
here what I am doing is I am telling that I want to take image data set from directory. I am giving the directory location above. Now what I am telling, I want all the images to be picked up randomly. So for that I am telling shuffle equals to 2. What now each image comes under four types of things. Okay, that is healthy leaf and three other digits. Okay, so I want my like images to be labeled as in it should automatically pick up the names where it is coming from. So here I have put labels equals to infer, that is it will automatically pick up in which class it is.
Okay.
Okay, so suppose from a data set I have picked up some random image. When I go to check, it is and comes under healthy leaf. Okay, so this label equals to inferred will pick up like this leaf is equals to healthy leaf.
Okay.
Now batch size is already explained. Image size I have already explained. Validation split as in I am taking 90% of the data as my training data, 10% of the data as my validation data. You can change this one.
Yeah, but as a data science, the best practice is to divide it into like 80/20, right?
You can do that. Like it won't affect much. You can do 80/20 also.
Okay. Okay.
Okay. Now what I'm telling, all the things that comes under training data set are a subset of training. Okay, I am making a huge umbrella under which I am telling that these are all the subset of training data set. Now I want like my Python code to consider all the colors under an image as RGB, primary colors, red, blue, green.
Uh, can you
Now,
can you come this part, the subset training, or can you explain this?
huh. So all the like it is a training data set, right? So I am telling this is a part of set and subset, all those sort of things,
Yeah.
union, set,
Yes, yes.
mathematical terms.
Okay.
Huh. So I am telling this see all the data comes under single set.
Okay.
Now I am dividing the single set into 90% training, 10% validation data set. So I am naming that my 90% training data set should come under training.
Okay.
And rest, if you see, I am put downwards validation. That 10% will come under validation.
Okay. Got you.
And the seed 42 I have picked up because I want to like parameterize my random picker.
Okay. That means.
Uh, see, I am currently taking random image, right?
Okay.
So I want to make sure that this random image, whenever I use this randomization, I want it to work according to some constant parameter.
Okay.
It won't be like running randomly. It should have some single parameter upon which all the other random things should work.
Mm.
This is highly like computer based thing. It won't affect you. So like you can ignore this. Or like if you want some in-depth knowledge like what is seed, what is random generator, you can search online as well.
Yeah, sure. Got you.
So scroll down. Yeah, here if you see what I'm telling is like after dividing the data set, I am printing how many things are there. So in total, I have this many files belongs to this much class, and I am using 90% for training. Then I am using 20% for validation, etc., etc.
Okay.
Also, now I have
Yeah, every file
now.
got one question. Every file got 200 files we got, right? Every file got 128 images, right? Okay. Thank you.
Now what I'm telling is now each data set comes under a single class that we have used label for, right?
Okay.
Now we have four class like common rust, gray leaf spot, corn healthy, and northern leaf blight. These are all the four class of images that we are considering.
Okay.
And I am defining that my figure size should be 20 by 15 only.
Okay.
Go down. No, go to the code part. Scroll a little bit up. Okay, okay. Now here, this SNS, what I'm telling is I want my graph image like little downwards, SNS one. This one. So what I'm telling is here I want my graph background to be white colored with some grid lines. Okay, if you see the graph, it has white color with grid lines.
Okay.
Go to the graph downwards.
Yeah, it's white color.
See, it has white background with grid lines. Okay, so I'm telling I want like this way.
Okay.
Now what I'm in this data imbalance I am doing is to see like how many images comes under each of the different classes. Okay.
Okay.
For test run, I have 50 image in each class, but when you run with the original dataset, it will give you different number of images under each dataset. So what I'm doing is I'm making a code that I want the number of image under each class, and I want to simply plot it like making a bar plot. And at the x I'm giving all the names, and the y should be my value, like how many number of images comes under each category.
Okay.
So like go to the graph. Yeah, so like this way I'm plotting a graph that under each category I am getting this much images.
Okay. So
And
I have one question. Uh,
mhm.
we are having the equal number of types.
This is dummy data set. In actual data set it won't be like this.
Okay.
This I have used dummy data set.
Okay. So if you run with the original data set, these things are all change, right?
It will change.
Okay. Yeah.
Yeah, go down. This graphical part is over. Okay, now
One question.
I want, sorry.
Uh, in this directory, we are going to the 200 images, 200 files are there, right?
Mm-hmm.
The 200 files.
200 are not files. 200 like those files are referred to images.
Okay. The 200.
For dummy data set, I have 200 images.
Okay. I'm just asking 200 files belongs to four classes, right? This question.
Those because this is like in technical terms, if we refer each object, computer object is referred as a file only.
Okay.
So scroll down. Now here, in this part, what I want to do is suppose if we have a different number of images under each class, right?
Yes.
But I don't want like my data science code to make a bias upon some particular class. Bias in the sense, suppose if you have a majority of boys in the class, okay, 80% boys in the class and 20% girls in the class. So if you going to pick up some random student from a class for a sport activity, maximum amount you will choose boys only. Am I correct?
Yes.
But I don't want that. I want to choose according to the ability of the student. Now how to make sure that our data science code don't randomly choose based on the like number of students, maximum number of students in the class, but instead upon the like feature of the student and something like that. You getting my point, right?
I'm sorry, I'm confused about this part.
Says I don't want my code to make a bias upon something that has a maximum number of images.
Okay.
I want my code to predict what type of class the images comes under based on the features.
Okay.
I don't want it to like predict based on the majority number of images that we have.
Okay.
Okay. So what am I doing is, first of I am defining a weight. Okay. So
Okay.
suppose, see, we have 80% student in boys in class. We have 20% girls in class, and I want to make a group of 6 students with equal number of boys and girls. Equal number of boys and girls means equal weights. Weights in here in the sense is percentage.
Okay.
Okay, it is a technical term. That's why I am used weight here. But for general term, you can say percentage. I want 50% boys, 15% girls, 50% girls.
Okay.
So what I will do, out of 80% student boys, I will pick like suppose I have to pick 6 students. Okay, so 3 boys I will choose.
4 boys. 4 boys.
No, no. Uh, uh, I want, see, in class I have 10 students.
Okay.
Suppose, in which 8 are boys and 2 are girls.
Okay.
Now I want to make a dance group of 4 students
Okay.
with equal number of boys and girls. So what I will do, I will choose 2 boys and 2 girls.
Okay. Got you.
Yeah. So weight of, so like the percentage of the girls used here are all the girls I've used,
Yes.
because before also we have 2 girls and now in the dance group I have 2 girls.
Yes.
So that will be 100% of the girls I have chosen.
Yes.
And what about the boys? So two I have chosen 2 boys out of 8 boys. So that is 25%.
Okay.
So that way here also I am doing the same thing.
Okay.
So based on the number of percentage and what I want to choose, I am just simply calculating the percentage out of total. See, if you see the calculation method, I am using total, and total divided by 4 classes. That is for a single average class, and I want to see what is the weight of each class.
Okay.
So this is a like generic. You understand the like example that I've given. Now I am doing the same thing only.
Okay.
Okay. So as, see here, if you see the weight of each class is 1. Why? Because each class has 50 number of images.
Okay.
That's why each of them has equal percentage, that is 1. What suppose if one of the class has 40, then what will be its percentage? 0.8, 80%.
Okay.
40 divided by 50 equals to 80%, right?
Yes.
So that way it will do the calculations.
Okay.
Okay. Now I have defined like my data science code should uh, like predict based on the weight of the class instead of the like total number of images of the class.
Okay.
Now if you scroll down, see, this part is like a main part. What am I doing is I am telling my Python code that for each single image that you will get, for each single image you will do 5 transformations.
Okay.
Okay, you will first of all randomly flip in horizontal direction. Okay, make one image, then you will random rotation in any direction with 20 degree. Okay, then third you will zoom any part of the image by 20%. Then you will randomly enlarge any part of the image by 20%. Then fifth, you will enlarge the width of the image any part by 20%. This whole 20% thing you can change accordingly, but the value should be around 0 to 1 only.
Okay. Got you.
Now after I made this 5 or 6 images out of my original image, what am I doing is I am looping it over all the images. Okay.
I have one question. Uh,
Mhm.
with this random rotation and zooming and hiding thing, you have chosen for 0.2%, 0.2, right? So have you tried any other number like 0.4, 0.5, and any observed like any accuracy differences like that?
See, there will be some accuracy differences, but it won't be much.
Okay.
See, why am I doing this? Because I want my data science model, okay, to be very robust. Robust as in, I want it to predict on any types of images I give. Like it shouldn't give me any error if I give the images in wrong orientation or something like that, in wrong angle or something. That's why telling my code that you should do this all random things so that my code will become more intelligent to reading all the images. Now, this for loop part, I am just simply displaying all the images and all the rotations and things that I have done above. So if you scroll down, say, if you see the first image, it is a normal image, okay? If you see the second, it has enlarged the middle part. If you
Yes.
see the third image, it has rotated it.
Yes.
If you see the fourth image, it is also doing some another thing, fifth image another thing, sixth image another thing. That way, like randomly 9 images are being created.
Okay.
This way, our code will try to learn and become more robust.
Okay.
Now, if you go down, okay. Now, okay, done. Here, what am I doing is now we have made the classes. Okay, we have like splitted our data set and all other things. Now, what am I doing is I want to initially show like what my data set look like. Okay, so this whole code, this one, what am I doing is first of all I am looping over my training data set. Okay, from each and every image I am going through, and if the image belongs to common rust or leaf spot or blight, I am just appending the images to that data frame.
Okay.
If you see, I am defining a data frame common rust, gray leaf spot, corn leaf blight at the second, third, and fourth line of code. So what
Okay.
am I doing is I am simply splitting my images now based on the classes it belongs to.
Okay.
Now go down. Now,
So yeah,
go down. Go.
no,
Sorry.
one question I have. So here
Mm-hmm.
we'll split the images in different 9 images, right? So in the
Mm-hmm.
images, we are going to group it, right?
No, no. See, the above thing, na, random orientation and all those things. Those we will use in the actual model. We are not going to like divide image now here. Okay, that's one thing. We are not going to divide images initially. We are going to divide images while we are running the model.
Okay. So here we have done the image 9 images, right?
Hmm.
So
Hmm.
part I'm asking that in this part we are going to
Hmm.
these 9 images types into this
No,
part.
no, no. We are not going to that 9 images part. We are going to the actual data set
Okay.
that we have splitted, na, training data set and validation data set.
Okay.
I am going there. I am taking random images. Okay. I am checking which part, like which class these images belongs to, and then I am simply putting that image into a data frame.
Okay. So we are going into the training data set and we are grouping here, right?
Ha, ha, ha.
Okay.
Now, if you scroll down,
I have one more question.
okay.
Data splitting is the 90-10% is going to be like the how it's going, how it's done. I think how it's gonna do because there are there is a chance, right? If 90% of all the images goes one side and the validation part have don't have the all the types of the
No, 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 no. It. That's why if you go upwards, I have like told it like that label should be inferred. I want I want from each label, I want it to shuffle between all the images. Those
Okay.
part of the things I've already taken care about.
Okay. Gotcha.
And this image data set from directory is a function only. Like it is a inbuilt function. So it will take care that it will try to approximately take equal or somewhat 5% up or down, like number of images from each classes under. It will not take like all the images from a single class. That is for sure.
Okay. Yeah.
Hmm. Go down. So after I have splitted my images into different classes now, saved into different data set, what am I doing is I am just simply plotting it. So I want to see like what my actual diseases look like.
Okay.
So if you see the images downwards this way, see here in Google Colab Notebook, you can change the setting to like make it a more images to be little bit. That we can do later words as well. But you got my point, right?
Yes.
So that way I'm like telling that this type of leaf belongs to this one, this type of leaf belongs to this one, etc. etc.
Okay. Oh, I think 10 minutes.
Sorry.
Our meeting is going to end in 10 minutes.
Don't worry, it will like we are coming at the end only. Go down.
Okay. You haven't explained this part. I didn't get it.
No, we are just plotting the images only. There's nothing to explain here.
I can explain this part. The subplot 2 comma 5 I plus 1
Sub
means.
Subplot in the sense I'm making two rows of five images. So if you go down, you will see for common rust we have two rows, each having five images.
Okay. Got you.
Okay, stay here. Now the first part auto tune. Okay, what an auto tune is a inbuilt function given by this what I can say uh, TensorFlow. Okay,
Okay.
and what it helps us to do is say we have various parameters and features coming from the images.
Okay.
Okay, and this auto tune will help us to optimize the system CPU and GPU utilization.
Okay.
It's just that it is used to make our process like whole training part and all other part such that like it will utilize the maximum amount of our CPU and GPU.
Okay.
Now here in the training data set, see what I am telling that from training data set I will fetch all the images and my buffer size as in like whatever will be my like images that I will pull at a one amount of like one period of time, that will be based on my system.
Okay.
If my system is very fast, it will take 3000 images at a single time.
Okay.
If my system is slow, it will take 128 images at a single time.
Okay.
So these all things are like depend. I have added so that like anyone in any of the computer it will run.
Okay.
Now this image say, okay, what am I telling is my image size is 299 to 299 in X and Y direction,
Yes.
and I am adding these three. Three in the sense I am telling that it will be basically of three main colors: red, blue, and green,
Okay.
primary colors.
Okay.
I am telling that my image shape is telling that my image size is 299 by 299 and the color is red, green, and blue.
Okay. This means that, right? The three colors.
Huh. This is I am defining we are using only three colors because those are the primary colors. Besides that, we don't need any color.
Okay.
We can make 1,000 colors using these 3 colors.
Okay.
So now I am defining my base model here. This is the first time I am defining my model here. So
We are going to building the model here from here, right?
ha.
Okay.
Here what I am telling, I will be using Inception V3 model. My input shape, like what will be my dataset shape look like? It will be like the one I have defined, 299 by 299 with 3 colors.
Okay.
Include top in the sense, do I want to include header? No, I don't want to include header.
Okay.
Or it has another meaning as well. I don't want to include the last layer.
Okay.
Okay, that I will explain in later what is layer and all. And weights. Here I have used ImageNet. Okay, ImageNet is like predefined, pre-trained data set, like you can say model that comes with TensorFlow. So I am using that only. It is best to use under image processing and all.
Okay.
So these are the parameters I have defined for base model. Now
Okay.
I am printing like what is my type of base model. Okay, so it is printing that activation 93 is the best model that we can use here. Now for the pre-processing part, I am telling that all the pre-processing should be handled using this one.
Okay.
TensorFlow Keras application Inception which is pre-processing input.
Okay.
Now, NV layer in the sense for our CNN model, we have multiple layers. Okay, go to Google and search what layers in CNN. Go to images.
Yes.
Say so whatever you are seeing in between. Na, in a single input, we are defining multiple features. Then from that multiple features, we are uh, uh, like dividing more and like converging. Those sort of things that you are seeing in between. Na, those are layers.
Okay.
Go to our code.
So cool.
So here what am I telling is, I first of all I am asking like what is the number of layers that my model currently has. Okay,
Okay.
and I am printing the number of layers. So my model has 311 layers.
Okay.
If you go to the Google, you will only see 3 or 4 number of layers.
Yeah.
But I have used 311 number of layers. So
That's
if I go explaining each, it will be like nightmare for you and for me.
okay.
We don't need to get into like basic like what is layers and all. Those you can see, it is like dividing each and every features into multiple parts. So for example, I have an apple. Okay,
Okay.
so what I can do is I can peel the skin of the apple and put it as one feature. I will take out the seeds of the apple and make it as another feature. I will make a juice of the apple and make it third feature like that. You understand, right?
Mm. Yeah. I know about something about layers. So it will map one layer with another
Yeah,
layer.
go through any like YouTube videos, you will get to know like what is layers.
Okay. Got you.
Then I am just simply yeah. So other printing is like I am telling like what is the like my uh, second last layer name and what will be the like my last layer name. Okay,
Okay.
second last layer name is used to like second last layer name is necessary because at that layer we are sort of like all the features we are mixing into a one. So if you go to the Google image once,
Yes.
if you see second last layer, second image, go to second image.
Analytical. Okay. Okay.
See, first of all, we have started with a single image, right? Then
Yes.
we are like dividing it and all other things. If you see at the second last layer, this red like blue dots,
Yes.
somewhat we are mixing it, right? We are mixing all the features and drawing conclusions here. So this layer is the like most important, and the last layer is the like output layer only.
Okay.
Yeah, go to our code. Do one thing, send me a new link. This meeting is going to end.
Yeah, sure.